All right, this is section 2.5 on algebraic proofs. So looking at this problem here, solve for x, most of us are going to fall back on our algebra skills and say, well, x is going to equal something, and then you'll have an answer. What this chapter is going to require you to do is to slow down and write every single step. And so the first thing we would do, if you were going to solve for x, is we would subtract 4 from both sides of that equal sign. So this should not be new to you, the subtracting 4. But now I'm going to ask you, why? Why did you subtract 4? Who said? Who said you could do that? And up until now, we don't really have an answer for that. We subtract 4 from both sides of the equation sign because our algebra teacher told us to. And we kind of accepted that blindly and said, sure, why not? What this chapter is going to require you to do is to know why. Why can you make that step? And so we're going to be looking at some different properties. We've got a whole bunch of them listed here. They're in your book. Otherwise, they may be on a print-off. The addition property of equality, subtraction property of equality, multiplication property of equality, and the division property of equality. These first 4 are going to be the ones that I'm going to concentrate on in this particular lesson. Reflexive, symmetric, transitive, and substitution, we're going to be looking at a little bit later. But these first 4 are really nothing new. It's just a name for it. What the addition property of equality says is that if we have 2 things equal to one another, we can add c to both sides. You've been doing this for a long time now. You just didn't know why. Subtraction property of equality tells you can subtract c from both sides. Multiplication, multiply both sides by c. Division, divide both sides by c. You've been doing this for a long time without really knowing what you were doing. So now we're just giving a name to it. So going back to my problem here, 5x plus 4 equals 14. We're going to be able to justify every step that we make here. And the way we're going to organize that in what's called a T-proof, otherwise known as a 2-column proof. And we're going to organize what we're doing. So this first step here, the original equation, was just given to us. So I'm just going to write given. All right? So 90% of the time, your first step will just be given. Not all the time, but most of the time. The second step here, we subtracted 4 from both sides of that equal sign. The subtraction property of equality allows us to subtract from both sides of the equal sign. So you have the subtraction. And because I'm a mathematician and I'm lazy, I'm going to abbreviate sub prop equals. Subtraction property of equality. If I continue on with this problem here, solving for x, I would end up with 5x equals 10. And the reason I can do that, the reason I can write what I just wrote, is because I'm simplifying the problem. So I'm going to just go ahead and put simplify. Simplify. So I've simplified that problem. For the most part, if you're doing something that you're not sure if it has a name, if it's not subtracting or not adding, anything like that, we'll call it simplifying. Next, if I were going to solve for x, I would divide both sides by 5. And the property that allows me to do that is the division property of equality. So again, I'm going to abbreviate div prop. Board is running a little slow today, so that does say property, believe it or not. And then my final step here, if I actually do the division, 5 divided by 5 is 1x. 10 divided by 5 is 2. And then the reason I can do that is by simplifying. Simplify. So for the most part in algebra, you're going to have a property, simplify, a property, simplify. You're going to kind of go in that pattern. Not always, but for the most part. So those first four are what we're concentrating on. Reflexive, symmetric, transitive, and substitution we'll deal with in a different lesson. Now, see if you can figure this one out here. I'll give you a second to try and get this one. This is a little more of an algebra, or excuse me, geometry rather than just an algebra. To start you off, we'll have our T proof. There's my T. Now, that first step, there's no equation yet. So you have to make one. Looking at that figure there, I've got a line segment that's broken up into two different pieces. I know KL and I know LM, and I know KM. So if you think back to chapter 1, we can use the segment addition postulate to add these segments together. So the segment addition postulate told me that KL plus LM equals KM. And that was the segment addition postulate. You have to forgive my handwriting. It doesn't follow right now. You may not believe it, but that actually says segment addition postulate. Segment add post. Doesn't look like it, but that's what I mean to say. Then I can plug my parts in here. KL, that's the same as x plus 3, according to that top statement there. LM, that's the same as 2x minus 1, according to my picture. And Km is the same as 5x minus 4. So, wow, that looks bad, but x plus 3 plus 2x minus 1 equals 5x minus 4. So what I've done there is I've substituted something in. I've substituted x plus 3 for KL. So looking back here, that bottom property, the substitution property, says that if A equals B, if KL equals x plus 2, then B can be substituted for A in any expression. That should be x plus 3. So KL is the same as x plus 3, so I've substituted that in. This is the substitution property. All right. Now, I'm going to simplify my problem here a little bit. I'm going to combine all my like terms. I've got 3 x's. I've got 3 minus 1 is going to give me plus 2 equals 5x minus 4. And again, I've just simplified my problem. Simplify. Boy, if you can read this, good on you. This is my 3rd time trying this, so I'm kind of stuck with what's given. So now we're getting to our algebra stuff here. If I want to get x all by itself, I want to subtract 3x from both sides. Minus 3x, minus 3x. And again, since I'm subtracting, I'm going to use the subtraction property. Subprop of equality. I'm going to end up with 2 equals 5x, or excuse me, 2 equals 2x minus 4. And I've just simplified the problem a little bit. All right. Myself a little bit more room. Now the x all by itself, I'm going to be adding 4 to both sides. And I can do that because of the addition property of equality. This takes a long time to do. You're really going to have to slow down and write down all your work, which some of you might have a hard time with. But it's important to know what you're doing and to be able to justify it. So I've got 6 equals 2x, and I've simplified. And next step, almost done here. I'm going to divide both sides by 2. That's going to be the division property of equality. It says division property of equality there. And the 9th and final step of this problem. 6 divided by 2 is going to give me 3. And 2 divided by 2 is going to give me 1x left over. So 3 ends up equaling x. And that was simplifying. And there we go. I can hardly read that, but I'll read them through again. Step 3 was simplify. Step 4 was substitution property of equality. Step 5 was simplify. Step 6 was the addition property of equality. Step 7 was simplify. Step 8 was the division property of equality. And step 9 was simplify. Hopefully you could follow that. I apologize about the poor technology, but today was just not a great day for it. So, okay, that's all I've got for you. So good luck on these, and try some examples.